Hey everybody, in this video we are looking at example 52 on our pre-calc final exam review playlist. This example is also going to appear on an inequality playlist. These types of inequalities are taught in a number of ways, and I find that the method I have, the technique I have for all of you to learn how to do these is the best one, especially if you've gotten really good at graphing. If you have mastered this, you have no idea how well prepared you will be to have a really robust understanding of calculus, okay? It's going to help you tremendously. So when we solve an inequality like this one, this is a rational function. When we solve one like this, we want to know when is it greater than 0. What could this rational function look like? It might look something like this, just drawing in some asymptotes, maybe a branch over here, maybe a branch over here. So it's saying, when is this greater than 0? Well, if it's asking me when is it greater than 0, it wants me to identify this area there and that area there, not the yellow, okay? And then I use the x values to describe. Greater than 0 above the x-axis, okay? So that is what we are going to look at. So I also have a video, it's in the description box for this as well, the best way to graph rational functions. I believe it's one of the first videos after the pre-calc final exam playlist. You know, we're numbering 1 through whatever at the bottom of that playlist, okay? So look for it. It says best way to graph rational functions. You're welcome. Okay, so let's get into this right over here. Now, is this one supposed to be green? No idea. Let's do this color. Okay, x-intercepts. Now, for starters, I'm allowed to dive into this. Quick little sketch-a-rooney. I'm allowed to do that because it's already got 0 and everything's got a common denominator. That makes this technique really quite easy. X-intercepts, you would know from graphing rational function lesson. You take the numerator and set it equal to 0 and solve. That means my x-intercept is at 6, 0. You should, if you're in pre-calculus, more or less be able to do this in your head. If you're a little bit weaker, you write it down. I'm skipping steps for the time being. Y-intercept. You should memorize how to get your y-intercepts. You plug in 0 for x, those are gone. -6 over 2 is -3, so my y-intercept is 0, -3. Now, do you really need a y-intercept? You don't really need it, but we use it to figure out a little bit more about where the branches will be. After that, vertical asymptote is where I have an infinite discontinuity. That comes from setting your denominator equal to 0, and that means it'll be at x equals -2. That is the equation of the dashed line. Oh, also, invisible parenthesis first power, so that's a linear behavior. Invisible parenthesis first power, so that's odd behavior. So the branches will point in opposite directions, in case you forgot about that. Then back to this. Now, end behavior, which I don't like to call horizontal asymptotes because it's not always horizontal. In this case, leading term over leading term, I have x over x. That perfectly reduces to 1, so it is a horizontal line at y equals 1. It isn't always. If the top power is bigger, it's some other polynomial, maybe a linear, quadratic, whatever. And you get the actual equation by doing synthetic or long division and ignoring the remainder. And you should know when you divide, your power goes down by 1, okay? If you don't know that, you're in trouble. Now, I'm going to do a little light sketch, okay? So I have an x-axis and a y-axis. It doesn't need to be to scale if it's labeled, okay? So, x-intercept, 6. Y-intercept, -3. Okay. Vertical asymptote, -2. Okay. And behavior, y equals 1. Like that. Now, I have all the things I need to draw this picture. How so? Well, I'm going to approach my asymptotes. That's what they're there for. I'm going to connect my y-intercept and my x-intercept. So I'm going to go and ride up along that asymptote forever and ever, okay? Then here I'm going to slice through and forever and ever. This was linear, so I had to slice through pretty straight, okay? Then odd asymptotic behavior. This branch is pointing down because of the points I had. And being that it's an odd asymptotic behavior, that means this side must be pointing up. Boom. So that is a part of my drawing right over here. Now, I got to answer the inequality. I'm ready to go. That's it. We are ready to go. So the numbers I care about most are the 6 and the -2. Those are usually the most important. The 6 and the -2. So again, I'm looking for when this is going to be greater than 0. So 0 is the x-axis. Greater than 0 means above. Now, it's a little hard to see on the far right, but here, that little piece is going to be above. So now, how do I write my answer? So I'm going to just shade over it a little as well. So this, yes, all this stuff, good to go. This is all greater than 0. And then from here, well, not including that point really. So from there, open circle, and then forever going to the right, okay? So we're going to write from -infinity, x values, okay? This is -infinity that this arrow is pointing at, until -2, where the asymptote is, with a parenthesis, because you can never reach -2. Union, where am I picking up again? Now, sometimes the x-intercept could be included if it was greater than or equal to, less than or equal to. In this case, it is not or equal to. It is just greater than. So it's going to start right after 6 until infinity. And that is our final answer. If you had to transfer that to a number line, fake it till you make it, right? If you understand it how I did it, you will have -2, you will have 6, you will have an open circle, you will shade, okay? And open circle and shade, and really that's it, okay? Positive, negative, positive. You could fake your interval testing if you need to, and that's the final answer. There are 2 more rational inequalities in this particular playlist, and on the screen right now you have 2 playlists. You'll have a PreCalc final exam review, and you will have inequalities. So you go where you need to go. And if that was helpful and you got it right, go ahead, thumbs up. If not, thumbs down. That's it for now, and adios.